1 tayo.
3,
Lang yun,
1.
lang yun.
Yes.
People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malulenyo.
Teleradyo is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa Teleradyo. Please take time to send your feedbacks via Teleradyo Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow bit.ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradyo Mu kung saan ang feedback mo, suggestions nyo ay mahalaga sa Teleradyo.
Makinig, manood na sa Teleradyo. Makinig, manood na sa Teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo.
Hello there, Del Pilarians. I'm Sir Michael Pantorillo, and welcome to another fun and exciting learning experience today in this episode of Teleradyo Marcelo, ang telearalan ng bawat Malolenyo. We are now in the 7th week of our 3rd quarter, and this afternoon, I will help you with an hour of easy learning in statistics and probability. So, let's get started. Here are the content standards and performance standards for today's lesson. For content standards, the learner demonstrates understanding of key concepts of estimation of population mean and population proportion. For performance standards, the learner is able to estimate the population mean and population proportion to make sound inferences in real-life problems in different disciplines. So, as an objective for today's session, our goal is to illustrate the t-distribution and identify percentiles using the t-table. But before we proceed, let's see if you can recall these terms as they are significant in our discussion later on. Definitions will be flashed, and I encourage you to key in your answer in the comment section below. So for the first one, it is the standard deviation of the sampling distribution of a statistic. Again, it is the standard deviation of the sampling distribution of a statistic. So I'll give you 10 seconds. I encourage to type in your answers at the comment section below. So time's up. If you answered standard error, great job. You're correct. Standard error is defined as the standard deviation of the sampling distribution of a statistic. So first statistic is the sample mean. So standard error simply says how accurate your sample mean or how far away your sample mean is from the actual population mean. So next, it tells how many standard deviations away a value is from the mean. Again, it tells how many standard deviations away a value is from the mean. So let's see if you recall. I'll give you 10 seconds. So 3, 2, 1. So if you remember, the answer is z-score. If you got it correct, congratulations. Now let us recall the formula for z-score. So z-score is equal to the value, the distance of the value from the mean, from the population mean, all over the standard deviation. So this formula asks how many standard deviations fit in between the distance from the value of the value from the mean. So for example, if the distance of the value from the mean is somewhat approximates the numeric value of the standard deviation, so our z value in turn will equal to 1, meaning the value, the distance of the value from the mean is 1 standard deviation away. So if the distance fits 2 standard deviation, our z-score will equal to 2, meaning the value is two standard deviations away from the mean. So next, this one has been discussed to you when you were grade 10. It is a measure of position with data divided into 100 parts. It is a measure of position with data divided into 100 parts. So let's see if you can recall this definition from your grade 10. I'll give you 10 seconds. Type in your answer in the comment section below. So, time's up. If you remembered it correctly, the answer is percentile. So congratulations if you guessed it right, or got it right. And as a refresher of what percentiles are, here is an example. Consider this group. Consider a group of 20 people arranged by height from shortest to largest. You are said to be the 80th percentile. It only means that saying 80th, you are the 80th percentile means 80% of the group is shorter than you. So, meaning you are most likely to be so you are part of the other tallest 20% in the group. Okay, so here are the questions. To review our understanding of percentiles. So let's see. For the first question, if Peter is higher than 75% of the class, what is his percentile rank? Again, if Peter is higher than 75% of the class, what is his percentile rank? So I'll give you 10 seconds to answer or think about what the answer is. Okay. So I encourage again to comment your answers in the comment section. So if you answered 75, then you are correct. So as stated from the previous slide, so this problem tells us that 75% of the class is lower than Peter, making his percentile 75. So next question, for question number 2, the percentile rank of Rose's score is 60. What percent of the class does her score belongs? Again, the percentile rank of Rose's score is 60. What percent of the class does her score belongs? I'll give you 10 seconds again to answer the question. So think about it carefully. So I'll extend for another 30 seconds. So think about the question carefully. So the question being asked is, what is her score? So her score belongs to what percent of the class? Think about it carefully and type in your answer in the comment section below. So if you answered 60%, then you are wrong. Apparently, the answer is 40%. Why? Having a percentile rank of 60 means that Rose's score is greater than 60% of her class. So to visualize, imagine this is the scores of her class. So Rose's score probably somewhere here, and being 60th percentile, means that 60% of the class is lower than your score. 60% is lower than Rose's score, meaning Rose is part of the 40%. Uh, Rose is part is the, Rose is part of the 40% in her class. Sorry. Okay. So if you got it right, congratulations. So moving on, going to our main topic for today, let us look at the formula for z-score and observe the similarity with the formula for our main topic, which is t-distribution. So here with z-score, x being the observed value minus mu being the population mean all over the population standard deviation. So on the other hand, with t-score, so t is equal to x bar being the sample mean minus the population mean all over standard error. So instead of using standard deviation, t-distribution actually uses standard error instead, with S being the sample standard deviation, and N the sample size. And we will see why as we look at their properties. So, like the normal distribution or the z-distribution, the t-distribution is said to have a smooth shape. So both of them, z and t distributions, happen to have asymptotically approaching zero, tails approaching asymptotically to zero, but never touches. So it goes on to infinity. So t distribution and for t distribution and for normal distribution, it goes on. So that gives them a smooth shape. Also, both z and t distribution is symmetric. What do we mean by symmetric? So both of them have a mean of 0 as their center. So a mean of 0 as their center. So being symmetric means that the right portion of their distribution is equal to the left side, or meaning the left side of the distribution is equal to the right side. Is equal to the right side as seen in this graph. So a feature to note is that t-distribution tends to look like normal distribution as the sample size increases. Shown in this image, how heavy the tails are see how heavy these tails of the t-distribution if their n sample size is smaller than 30. And as the sample size gets close to 30 or is greater than, so the t-distribution resembles this z-distribution more and more. That said, let's have a look at this decision tree. So if you know the standard deviation and the sample size greater than 30, it is recommended to use z-distribution. But if you don't know, if the population standard deviation is not known, it is always recommended to use the t-score instead, because normal distribution or z-distribution assumes that the population standard deviation is known, while in t-distribution, it does not. So let's say that you know the population standard deviation, but your sample size is not sufficiently large or below 30. So it is a good practice to use t-score still, even though you know the standard deviation. So t-distribution is most useful for small sample sizes, as well as with population standard deviation not known. In this case, if you know, if you know the population standard deviation, we should replace the sample standard deviation with the population standard deviation. So let's take a look at the formula again. So t being equal to x bar minus mu all over standard error s over square root of n. S being sample standard deviation and n sample size. So here, since we already know the population standard deviation, in this case, we can use it directly in this formula instead of the sample standard deviation. Okay. Lastly, an interesting feature of the t-distribution is this degree of freedom. So what is degree of freedom? Degree of freedom refers to the maximum number of logically independent values which vary in the data sample. So basically, it just corresponds to the value that is free to vary in a data set. So as an example, we have a set of with 3 elements, so 1, 2, and 3. So we know that the average of this element is equal to 2. So let's take the average by adding the number of all the elements and dividing them by their total number, which is 1, 2, 3, 3. Now, for the first element, it is free. It has a freedom to be any number of choosing. For example, it happens to be, let's say, 2. Then on the second element, it also has a freedom to be any number. For example, let's say 1. But on this third number or third element, it cannot be any number aside from the specific number that will satisfy the equation to have an average equal of 2. So this third element has to be 3 and nothing else. No freedom to be any other number. So in this case, with 3 elements, we only have 2 degrees of freedom. So in general, we define degrees of freedom equal to n as the sample size minus 1. So in this example, we have n equal to 3. So minus 1 gives us a degree of freedom of 2. So next, another term significant in working with t-distributions is the right tail area. It simply means that it is the area on the rightmost end of the t-distribution. So this one is so t-distribution has a fatter tail. So let's draw something more accurate, but the point still stands. Right tail area is the area in the rightmost end of the distribution. And later on, we will see that if we are given a percentile, for example, 70th percentile, it just says that 70th percentile So this area in the distribution corresponds to 0.7. So why 0.7? With the knowledge that the total area of the distribution is equal to 1, 70% of that 1 is 0.7. So this area right here has an area of 0.7, leaving us with the other right tail area, this one, to be 0.3. So 1 minus 0.7, which is equal to 0.3. And we'll work more with this in the following slides. But first, let me show you the t-table. So given the degree of freedom and the right-tailed area, we can look up what is the corresponding t-value from their intersection. So these rows right over here, 1, 2, 3, etc., corresponds to the degrees of freedom. Well, the columns the columns represent the values for area, the right-tailed area. For example, we have a degree of freedom of 2 and an area of 0.25. So their intersection corresponds to this t-value right over here, which is 0.816. Yeah, 0.816. So let's go ahead and show what I mean with examples. So here, in the first example, identify the t-values number of samples is equal to 7 and has an area equal to 0.05. So from the given, we can identify immediately what is the degree of freedom, which is equal to the sample size, number of sample minus 1, which is 7 minus 1. So the degree of freedom is 6. So let's find that in these rows. Degree of freedom corresponds to rows, area corresponds to, and the column corresponds to the area. And this area right over here is said to be 0.05. So let's look that up from the column 0.05. And the intersection of those two happen to be this t-value, 1.943. Therefore, the t-value in this particular example is equal to 1.943. So for the next one, we are asked to find the t-value whose degree of freedom is 20 and the area being 0.01. So as straightforward as this is, so we just have to look up for the degree of freedom, which is equal to 20, and the area equal to 0.01. So here in the upper right corner. So their intersection has to be this corresponding t-value, which is equal to, so t is equal to 2.528. So next example, we are asked to identify the t-value of the following percentiles given the number of samples. So as we mentioned earlier, so letter A, given a distribution, 95th percentile just means that the leftmost part of the distribution corresponds to 0.95, leaving the other side equal to, so we subtract the total number of area of the distribution minus the left side area, which is 0.95, leaving us with 0.05. Therefore, our right tail area over here is 0.05. Then, for the degree of freedom, we know that it is calculated by subtracting 1 from the sample. So n minus 1, 30 minus 1. So we have a degree of freedom equal to 29. So we look the values up here in this t table, with df being 2.9, or sorry, 29, and the area being 0.05. So in this column, here is the area, 0.05. Their intersection in return happens to be this corresponding t value. T is equal to 1.699. Okay, so next we are asked to find the t value of the 90th percentile given a sample of 20. So same procedure, we visualize the distribution. So 90th percentile tells us that the left side of the distribution is occupied 90%, which gives us the area of 0.9, leaving the other remaining rightmost area to be 0.1. Again, we got 0.1 by subtracting 0.9 from 1. So 1 minus 0.9 equals 0.1. This assumes, so this is because the total area of distribution is always 1. Having this right tail area of 0.1, we can now solve for, so we solve for degree of freedom first, which is n equals 20. So 20 minus 1 equal to, which is equal to 19. We look that up in the t table. So df 19, area 0.1, right over here, having an intersection of, so this t value. So t therefore is equal to 1.328. So next, so for this problem, Rowena wants to test a randomly selected 20 students for her study. So having a sample size less than 30, it is rightful to use the t distribution. So she wants to find the t value for the following percentiles. So here, again, same procedure as before. 75th percentile tells us that this part of the distribution has an area of 0.75, leaving the other area, which is the rightmost area, to be, so 1 minus 0.75, which is 0.25. So the right tail area has to be 0.25. Now, since the degree of freedom here is 20, or the sample size is 20, we can find the degree of freedom by subtracting 1. So n minus 1, which is 20 minus 1. Therefore, we have a degree of freedom equal to 19 for this particular problem. So let's look up 19, and let's look up 0.25, which is right over here. Their intersection corresponds to a t value of So the t-value is equal to 0.687 or 0.688. Notice how we've been looking up the t-value without using the formula just yet. Okay, so next for the fifth percentile. So fifth percentile says that, so fifth percentile says that so fifth percentile tells us that this part of the left most part of the distribution is equal to has an area equal to 0.05 because fifth percentile refers to 5% of the distribution. So 0.05, which leaves us for the rest of the area to be equal to 0.95. So we got this by subtracting 0.05 with 1. But as you can see, with this area, we don't have such value in this t-table. So how do we solve for this? So with the knowledge that distributions are symmetrical, so symmetrical in nature, having a center at 0, we know this 0.05 as the area. But if we flip it around the mean or the center, so around this center, we flip it since it is symmetrical in nature. So this 0.05 right over here will land on the same spot as this one over here, 0.05. But since we flipped this distribution, so this area now has to be negative. So as well as the t values we were supposed to get will now be equal to negative. So notice that when we flip, this part right over here is now the rightmost area. So we end up being able to use the t-table just by flipping. So 0.05 in this rightmost area has an intersection with our degree of freedom 19 to come up with this t value. So bear in mind that our degree of freedom is still 19. So we have a t value equal to 1.729. But don't forget that we flipped this one, so we may be able to use the t-table. So we'll have to write in the t value as a negative value. Therefore, the t value is equal to negative 1.729. Next, so we were asked to find the 60th percentile. So same problem, so meaning the degree of freedom is still 19. So how do we find the 60th percentile? Same process again. 60th percentile just means that 60% of the left hand side has an area of 0.6, leaving the other right tail area to be 1 minus 0.6 equal to 0.4. So we plot that again. So degree of freedom 19, and the area 0.4, leaving us with an intersection. So this one, t value equal to 0.257. Next, the 40th percentile is asked. So given another distribution, so it is said that 40% of the left-hand side has an area of 0.4, leaving the rest of the right tail area to be 0.6. Again, we got 0.6 by subtracting the total area of the distribution, which is 1, by 1 minus 0.4, this area. So apparently 0.6 is again not in this t table. So how do we solve for it? So we flip it again. So by flipping it along its mean, which is 0. So 0.4 lands here in the rightmost area. But since we flipped it, we negate the value. So we will still be using 0.4, but the equivalent t value in this table has to be negative. So in this case, 0.4 still. So the intersection still with df equal 19 is this corresponding t value. So t is equal to, this time it's negative. So t is equal to negative 0.257. For the 90th percentile, again, so this just means 90% of the distribution corresponds to having an area of 0.9, leaving 1%, 10% in the right tail area, in the rightmost end. So which leaves us with 0.1. So we eyeball it again. We look it up here in the table. So 0.1 here, and still 19 have an intersection equivalent to this value. T is equal to 1.328. So next, so for your assignment, so make sure to take a screenshot of this assignment, or you can write it down. So yes, I'll give you time. So this has been a very productive afternoon. You have a good understanding. So you now have a good understanding of percentiles and t distribution. I'll leave you with a set of problems, so this set of problems, as homework to encourage you to apply what you have learned this afternoon. Doing this activity at home will help you retain the information in long term. So that concludes our discussion for the afternoon. Visit your Google Classroom for instructional materials and other activities to help you improve your math skills. Make a habit to tune in to Teleradio Marcelo to ensure a fun and exciting day of learning. I would like to thank our department head, Ma'am Gladys Bondok of ABM Math and Research Department, Sir Jassy Gabriel Torres for this session script, and the rest of the broadcast team. Also, many thanks to our dear students for supporting Teleradio Marcelo, ang telearalan ng bawat Maloleño. I'm Sir Michael Pantorillo. Have a blessed day, and see you on our next broadcast. Thank you.
Teleradio is always at at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa teleradyo. Please take time to send your feedbacks via Teleradyo Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow bit.ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradyo Mu kung saan ang feedback mo, suggestions nyo ay mahalaga sa teleradyo.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo sa